All right, so here is an example of how to do long division with polynomials. So in fact, the process we're going to use for this is pretty much exactly the same as regular division. And in regular division, you generally, or regular long division just with numbers, we have all of our place values in order. So that's actually going to be the first step with this. I see that the divisor is all mixed up here. I'm going to go ahead and put it in order from greatest to least. 6x cubed is my first term. And again, x cubed, no matter what, is going to get big way faster than any of these other terms. Then just continuing on, 10x squared, take care of that one, plus x plus 8. If you notice, I'm underlining all of them. That's so I can account for which ones I've already transferred down. Just a little trick to make sure I don't end up with duplicates or I don't forget one or something like that, something silly. All right, so here I have 2x squared plus 1 for my divisor. Now, in this case, we actually would have to do this with long division. The reason being that we have an x squared term here. This is not a linear divisor. That x squared term and the 2 make it impossible for us to divide this using synthetic division. So long division is our only option. So now I'm going to go ahead and create that, what should be a very familiar long division sign. I'm going to put my divisor on the outside. So I have 2x squared plus 1. And on the inside, I put 6x cubed plus 10x squared plus x plus 8. Now, for this particular type of problem, all we're really going to focus on is our lead term here, and then whatever lead term we have for the divisor, and our divisor will change as we go down. But I'm just going to look and see what number times 2x squared is equal to 6x cubed. Well, 2 times 3 gets me the 6, and x squared times x will get me the x cubed. So if I take 3x times 2x squared, that's going to give me a 6x cubed down here. Okay? And then I go ahead and I take the 3x times, and there's something that I definitely meant to do with this. These columns, if you notice, they're in order. So you want to keep everything in the right column. So that 3x should actually stay right here because that's the x column. I apologize. All right? Same thing though, 3x times 2x squared is equal to 6x cubed. 3x times 1 is going to give me 3x. And I'm going to go ahead and put that right here. It's positive 3x in my x column. Okay? Now, moving right along, I do want to remember that I am actually subtracting these just as you would in regular long division. Okay? So 6x cubed minus 6x cubed is 0. And I'm actually going to go ahead and I'm going to distribute this, and I'm going to put a plus 0x squared there just to kind of hold the place. That's not necessary, but it's not a bad idea either. I'm going to distribute this negative to each and every term. Okay, and I get a negative 3x there. Now I'm adding, and again, I'd still get the 0 there. 10x squared plus 0x is just 10x squared. And x plus negative 3x is just negative 2x. Okay. Moving right along, I can go ahead and see that, or I need to drop down my next term, and I'm going to get 2x squared times, and I need to figure out what number times 2x squared is going to give me 10x squared. Well, 2 times 5 will get me the x, or the 10, and then I already have an x squared, so I should be in good shape. 5 times 10x squared is going to give me negative 10x squared. I'm sorry, positive 10x squared. Getting a little ahead of myself there. Okay. And then the 5 times the 1, well, that's going to go over here in my 1's column. And then remember, we're subtracting. I'm not going to distribute the negative this time, although you can. Now I have 10x squared minus 10x squared, which is just 0. Negative 2x minus, well, there's nothing there, so that's 0 is just negative 2x. And 8 minus 5 gives me positive 3. Now, this is our remainder. Now, one of the things that you should have learned back when you were doing long division with just kind of regular numbers is that you can take that remainder and it can actually become your numerator. Okay? And your divisor becomes your denominator. So we're going to go ahead and do that, and we get plus negative 2x plus 3 over 2x squared plus 1. And that's another way that we can write our remainder, and it is the preferred method. Because if we were to take 3x plus 5 plus this fraction and multiply it by our divisor, it will give us our dividend.